the normal incidence the plane of dielectric boundary. Okay. Second, the boundary conditions between the dielectric and the dielectric, E tan 1 is equal to E tan 2, or E1 is equal to E2. E tan 1 is equal to E tan 2, or E1 is equal to E2. So E1 is a combination of two functions, EI plus ER. Since the left hand side, the dielectric 1, having the incident beam and the reflected beam. And in the right hand side, the dielectric 2 is having only the one incident transmitted beam. So ET in electrical field. And in the magnetic field, the same thing, HI minus HR is equal to HT. Okay. We know that eta is equal to, or the eta 1 is in the left hand side, the dielectric 1. So E1 by H1, or you can say EI by the HR and an instant. It is also similar to that eta 1 is equal to ER by HR, because reflected beam and the incident beam both are in the same dielectric 1. And eta 2 is equal to ET by HT, the ratio between of electric and the magnetic field. So HI is equal to HI plus HR is equal to HT. Now from this equation, what is a HI is equal to EI by ET? EI by the eta 1. EI by eta 1 plus the same thing, and HR is equal to, HR is also the EI by ER by eta 1. ER by eta 1. But it is in the minus. Why it is a minus means, so I already explained the diagram itself, minus HR. The reflected beam is in the opposite direction, minus HR it is. So minus ER by this ER, not the I here. ER by HR. HR it is in the negative direction. The minus is equal to, from this equation, the ET by HT. HT is equal to ET by eta 2. ET by the eta 2. So 1 by eta 1 into EI minus ER is equal to ET by eta 2. Okay. Otherwise, EI minus ER is equal to eta 1 by the eta 2 ET. Let it be the equation 3. When I'm taking this one is a equation 1, equation 2, and the equation 3 here. Substituting the equation 1 and the equation 2 in this to get it is the reflection coefficient and the transmission coefficient. The reflection coefficient is gamma is equal to ER by EI, and transmission coefficient is a ET by EI, ET by EI function. So eliminating of R function to get it is a transmission, eliminating of T function to get it is a reflection coefficient. The first of all, if I am taking the EI minus ER and the ET, first find the transmission coefficient. What is the transmission coefficient? Transmission coefficient ER is equal to ET minus ER. So taking of equation 1, you can substitute it in the equation 3, minus of from the equation 1, what is the ER is equal to ET minus EI. ET minus EI. Okay. Is equal to eta 1 by the eta 2 and ET. Okay. Now we can simplify. This equation is only in terms of EI and the ET one. So minus of minus is a plus. EI plus EI is a 2EI. 2EI is equal to. Now in the left hand side minus ET, bring that in the right hand side. Eta 2 by, not the eta 2. Eta 1 by the eta 2. Minus is becomes of plus here, plus 1. Whole multiply into eta ET. Okay. Already in the right hand side, eta 1 by eta 2 into ET. Minus ET bring into the right hand side is a plus. Take the common of ET. The transmission coefficient tau is equal to ET by EI. ET by the EI. Now what is the EI coefficient one? After cross multiplying, taking off the LCM here. 2 eta 2. 2 eta 2. And eta 1 plus eta 2. Eta 1 plus eta 2 is a transmission coefficient. 2 eta 2 by eta 1 plus eta 2. To find the reflection coefficient, take the same first equation 1, substitute in the equation 3, eliminating of ET. Eliminating of ET. So EI minus ER is equal to eta 1 by the eta 2. What is the ET? EI plus ER. Now the equation becomes of total in the reflection coefficient and the, not the coefficient, ER and EI. Reflected electric and the incident electric. So bring the EI to left hand side. EI 1 minus eta 1 by the eta 2. Because it is getting towards its left hand side. And take the ER as a common. Now bring that minus ER in the right hand side, it becomes a plus 1 plus eta 1 by the eta 2. Simplify the function. So on both left hand side and the right hand side, eta 2 is the LCM of the common. You can cancel that one. EI into or multiplied with eta 2 minus eta 1 is equal to ER into eta 2 plus eta 1. Okay. Now the reflection coefficient gamma is equal to ER by EI. What is the EI coefficient here? The eta 2 minus eta 1 whole divided by the ER coefficient is eta 2 plus eta 1. Okay. The reflection coefficient. Transmission coefficient ET by EI is a 2 eta 2 by eta 1 plus eta 2. And the reflection coefficient gamma. Reflection coefficient gamma is equal to ER by EI. The formula is in terms of intrinsic impedance eta 2 minus eta 1 by eta 2 plus eta 1. Both the transmission and the reflection coefficient denominator is the same, but the numerator for the reflection is eta 2 minus eta 1. And transmission coefficient is 2 times of eta 2. Okay, this is a normal incident at plane dielectric boundary. At the dielectric boundary means the dielectric one having the parameters eta 1, epsilon 1, mu 1, and sigma 1 also. And in the right hand side, another dielectric 2 having the parameters sigma 1, sigma 2, eta 2, and epsilon 2, and the sigma remaining. Okay. The relation between of reflection coefficient and the transmission coefficient, you can see we got a transmission coefficient is equal to 2 eta 2 by eta 2 plus eta 1, and reflection coefficient gamma is equal to eta 2 minus eta 1 by eta 2 plus eta 1. So these are equations we derive for the plane of dielectric boundary. Now 1 plus reflection coefficient is equal to 1 plus reflection coefficient gamma is equal to 1 plus eta 2 minus eta 1 whole divided by the eta 2 plus eta 1. Now the cross multiplying the equation here to get eta 2 minus plus eta 1 plus eta 2 minus eta 1 whole divided by the eta 2 plus eta 1. So minus and minus plus it get cancelled. Eta 2 by eta 2 plus eta 2 is a 2 eta 2 by eta 2 plus eta 1. So this equation is the same as to the transmission coefficient. Nothing but the top. So 1 plus reflection coefficient is equal to transmission coefficient tau. Now we got the one relation. And the reflection coefficient, the magnitude of the reflection coefficient is always within the 0 less than or equal to 1 and less than or equal to 0 less than or equal to gamma less than or equal to 1. This is another relation. Okay. That will discuss it in the later. It is how what is x is equal to the magnitude of gamma is equal to 0. What happens when the S standing wave ratio and gamma is equal to magnitude of gamma is equal to 1. What is the standing wave ratio? It is a varies in between 0 to 1. What is the standing wave ratio? Also varies from 0 to infinite actually. Okay. The next we go for normal incidence of the plane conducting boundary. Another topic is normal incidence. Normal incidence at conducting boundary at a plane of conducting. Conducting means right hand side is a conducting and the left hand side is a dielectric. Okay, conducting medium. Now I'm taking here a boundary is in between of dielectric and conductor. Conductor means always we can remember the sigma. Dielectric means always you can remember with the epsilon. That is the compound parameters we have. When the dielectric is a perfect dielectric, epsilon is very much greater than. It's very high. Simply you can say perfect dielectric means perfect dielectric. Means epsilon is very high. High value. Perfect conductor means perfect conductor. Sigma is very much high. Okay. The remaining parameters also, that mu and eta, whatever it is. And I'm saying the sigma is very much high. What happens the eta? The eta value. See, we know the eta is equal to the formula we have from the propagation constant j omega mu by sigma plus j omega epsilon. So this is a formula we have for the intrinsic impedance. When the conductor in the conducting medium means you can say this is the difference between of take the shaded line here. This is a conducting. Okay. Sigma is very much high. So infinite, simply saying it is a infinite. The perfect dielectric epsilon is infinite. High means is a more infinite level. Sigma is also in the conductor very high. So eta is equal to j omega mu by sigma plus j omega epsilon. Sigma is very much high means infinite plus anything is again it is an infinite term. What happens when the eta is equal to j omega mu by infinite? Okay. Infinite plus anything is infinite. 1 by infinite nothing but the 0. The eta becomes of 0. That is in the next step, in the right hand side. Eta is equal to 0. And this is a dielectric epsilon 1, mu 1, and eta 1, and sigma 1 here. And similarly in this conductor, it is a sigma 2 we can taking as and eta 2, mu 2, and epsilon 2. In this conductor, the epsilon is very, very small. And in this conductivity dielectric, very, very small in the practical condition. But what happens the eta 2 here? Eta 2 is a 0 because in the conducting medium, the intrinsic impedance, the value is a 0. Okay. Value is a 0 means now you can see already we have the formulas are there. The transmission coefficient 2 eta 2 by the eta 1 plus eta 2 plus eta 1, and reflection coefficient eta 2 minus eta 1 by the eta 2 plus eta 1. So the conductor is in the second medium 1 and the medium 2. The first media, that is a media or the medium, is a dielectric medium. I'm saying it is a medium 1. And another medium, or it is a media, that is a second media, is nothing but conductor. In this eta, intrinsic impedance is 0, see, you can substitute the transmission coefficient 2 eta 2 by the eta 2 plus eta 1, or reflection coefficient eta 2 minus eta 1 by the eta 2 plus eta 1. Substituting the eta 2 is a 0. Why? Because the conductor in the medium 2 or the media 2, eta 2 is equal to 0. Why? The conductor, what we are saying, the sigma is very high. Sigma is very high means it is inversely proportional to the sigma, intrinsic impedance. Sigma is very high, the eta is a 0. Eta is a 0. So in the normal incidence at a plane of conducting medium, what is the transmission coefficient? It is also the normal incidence one. Normal incidence. If I'm taking here the EI and the HI, EI, the incident beam, the normal incidence, HI here, and there is no any transmission because of the eta 2 is a 0. Eta 2 is a 0 means 2 into 0. Numerator is a 0. Transmission coefficient is a 0. And the reflection coefficient, you can see the eta 2 is equal to 0. 0 minus eta 1, 0 plus eta 1. So eta 1 by eta 1, you get the minus 1. So total is here. Whenever the incident beam is there, the total is a reflected. Okay. The reflected. HR and the HR. And CR. ER and the HR. No transmission here. Because the conductivity is a more, intrinsic impedance is a 0. Since the eta is equal to 0, since the sigma is infinite, okay, there is no any transmission. The transmission coefficient tau is equal to 0. The transmission coefficient tau is equal to 0 in the conducting medium, normal incidence at a plane of conducting medium. Reflection coefficient gamma. Reflection coefficient gamma is equal to minus 1. Why it is a minus 1? Since the eta 2 is equal to 0 here. 0 minus eta 1 by the 0 plus eta 1 minus eta 1 by eta 1 is a minus. Okay. In the conducting medium, there is no any transmission. The totally it is reflected in the negative direction. In the negative direction. So the reflection coefficient is a minus. Transmission coefficient is equal to 0 for any normal incidence from dielectric boundary to the conducting boundary. But in the dielectric to the dielectric, the transmission coefficient is a 2 eta 2 by the eta 1 plus eta 2. The reflection coefficient is eta 2 minus eta 1 by eta 2 plus eta 1. Understood? It's a very important. Fully it is reflected, no transmission. If there is any dielectric in the dielectric boundary, it's not fully reflected. Some part is transmitted, and while some part is reflected. If there is any transmission, incident beam is there. Okay. Now we go find the standing wave ratios. SWR standing wave ratio. How we can find the standing wave ratio? The definition of the standing wave ratio is the ratio between maximum by the minimum value of the amplitude of the voltages. Standing wave ratio is defined as the ratio of maximum to the minimum. The maximum is when it is in the having the magnitude of the reflection coefficient. Let us see that also. Next topic is the SWR. I already told one relation we wrote here. That relation is a 0 less than or equal to magnitude of reflection less than or equal to 1. The standing wave ratio is also related to the reflection coefficient only. Okay. standing wave ratio. It is a ratio between of E max. It is saying as a VS E1S maximum to E1S minimum. ES is equal to the maximum value you'll get when 1 plus the magnitude of the reflection coefficient. Okay. And the minimum value 1 minus the magnitude of the reflection coefficient. Okay, S is equal to the standing wave ratio is the ratio between of the maximum to the minimum amplitude of voltage. That voltage in terms of the electric field we are taking the maximum value is 1 plus the reflection coefficient by the 1 minus the reflection coefficient. So actually you have to derive this equation as of the reflection coefficient is equal to the magnitude and the phase. The magnitude and the phase actually. That phase, we can take it as the reflection coefficient having the magnitude of reflection coefficient and the phase angle is a J phi in the polar form. Okay. And the standing wave ratio, the E1 and the E2, we can assuming E1 and E2 in the dielectric medium only, not the dielectric medium, conducting medium. The fully it is reflected. The fully it is reflected. There is no any transmission having only the reflection coefficient. That E1 is equal to, consider it as E1S. Okay, not the E1, E1S. Sorry. E1 into the phase angle e power minus j beta 1 into z plus the reflection coefficient of E1 into e power plus j beta 1. You can derive that equations. Forget about that derivation part. That reflection coefficient is equal to the gamma into e power j into phi, where the phi is the phase angle and the gamma is the magnitude of gamma is the nothing but magnitude function. It is E1 of S, E1F or E1S is equal to, in the standing wave ratio, E1S is equal to 1 plus the magnitude of the reflection coefficient whole multiply the EI. The EI E1 it is E1 bar. If it is a E1S minimum value, it is a maximum value. 1 minus the reflection coefficient E1 bar. Now I'm taking that the ratio between of these two, 1 plus reflection coefficient by 1 minus reflection coefficient magnitude. Now the relation between of S standing wave ratio and the magnitude of the reflection coefficient, S is equal to 1 plus reflection coefficient by the 1 minus reflection coefficient, and reflection coefficient is equal to taking the component and dividend of S plus 1 by the S minus 1. Okay, it becomes of S minus 1 by the S plus 1. Or you can assume the S is, what is the S? You see, the reflection coefficient is equal to, what is the S? 1 plus magnitude of the reflection minus 1 by 1 minus the magnitude of the reflection Yes, it is also the same thing, not like this, whole multiplied here. Minus 1 by 1 plus the reflection coefficient by 1 minus reflection coefficient plus 1. Now I can simplify this one. Definitely you'll get the same reflection coefficient. 1 plus reflection coefficient minus 1 plus 2 reflection coefficient in the denominator to the magnitude of the reflection coefficient. Because it is a minus, you'll get the minus here, and minus into minus is a plus, plus reflection coefficient magnitude, and here 2 reflection coefficient. And the take the comma here also 1 plus and 1 minus is there. You get the 2 to get cancelled. It is related to this reflection coefficient. Okay. When S is equal to 0, what happens when S is equal to 0? The reflection coefficient becomes of minus 1. See, when I am taking that S is equal to 0 here, 0 minus 1 by 0 plus 1. So reflection coefficient is equal to minus 1. Is one relation. Okay. When S is equal to 0, the reflection coefficient is equal to 1. When the reflection coefficient is equal to 0, when reflection coefficient is equal to 0, what is the S? S is equal to, now see here, 1 plus 0 by 1 minus 0. S is equal to 1. S is equal to 1. Means S is varies from here, see, 0 to 1. When it is S is equal to 0, the reflection coefficient is a minus 1. And S is equal to 1, the reflection coefficient is equal to 0. Okay. Reflection coefficient is varies from 1 to 0 less than or equal to 1 and less than or equal to 1. Suppose if it is a 0 and less than or equal to magnitude of the reflection coefficient and 1, we can assume. When the reflection coefficient is equal to 0, S is equal to 1. Okay, let's see this also. S is equal to 1. Less than or equal to S, less than or equal to, when reflection coefficient is equal to 1, 1 plus 1 by 1 minus 1. So infinite. See, this is another relation here. Means the reflection coefficient is a 0, the S standing wave ratio is a 1. Reflection coefficient is equal to 1, the standing wave ratio is infinite. So the range of S, is varies from 1 to infinite. The range of reflection coefficient is varies from 0 to 1. Okay, 0 to 1. Just remember these equations. What is the standing wave ratio in terms of reflection coefficient is 1 plus reflection coefficient by 1 minus reflection coefficient magnitude, that is also. And what is another relation is there for the reflection coefficient in terms of standing wave ratio is the magnitude of the reflection coefficient is equal to S minus 1 by S plus 1. Okay. So the two mediums, one is a dielectric medium, the normal incidence of the plane of dielectric medium, and the normal incidence of a plane of conducting medium. We derive the expressions of reflection coefficient and the transmission coefficients, and also the standing wave ratios. And in the standing wave ratio also, I have to discuss one point. The point is, fully it is reflected when there is a conducting medium, because there is no any transmission. Whatever we incident, since the no transmission means it is fully reflected. The back to that of the whatever the incident beam, the combining of the incident and the reflected, but it is the reflected is opposite direction. Opposite direction means the wave is always travel in the Z direction, because the magnetic field is in Y direction, electric field in the X direction, electromagnetic wave is in the Z direction. So it is reverse having the incident beam is there, fully it is reflected, means we can take it as from z is equal to 0 to the minus infinite. Why we are not taking the z is equal to 0 to infinite? Because there is no any transmission, only it is a reflection is there. The wave is again reflected towards negative direction or the negative real axis. We started that z is equal to 0, and for every lambda by 2, nothing but is a wavelength. For every lambda by 2, the wave goes to the 0. The standing wave ratio is a 0. Lambda by 2, another lambda by 2 means lambda by 2 plus lambda by 2, nothing but lambda. It's a negative values, okay. And minus, again the minus lambda minus lambda by 2, it becomes of minus 3 by lambda by 2, okay. For every lambda by 2 in the conducting medium, the wave is goes to the increasing and goes to the 0, and again it is increasing and goes to the 0 for every lambda by 2 of wavelength, okay. That is z is equal to 0. The next case it is a 0 of lambda by 2, that is nothing but minus lambda by 2, and another minus lambda by 2, it is a lambda minus lambda, another lambda by 2, that is minus lambda by 2 is a minus 3 lambda by 2, and minus 3 lambda by 2 minus lambda by 2 will get is of minus 4 lambda by 2, it is a minus 2 lambda, and so on, okay. Means for every 90 degrees we can say, that is 90 degrees phase shifting towards the 90 degrees. 180 degrees means total cycle, not the total cycle. Cycle means having the positive and the negative cycles. Positive cycle considered as positive or negative cycles, 180 and 180. Half part of that negative or positive cycle, we can say it is a 90 degrees. For every 90 degrees, okay, 90 degrees out of time phase. For every 90 degrees out of time phase, with the electric and the with the electric field everywhere, it is a becomes of the 0. The magnitude of magnetic field is a maximum at the positions where the electric field is a 0. Further, it is 90 degrees out of time phase with the electric field everywhere. Understood? Why I'm saying it is electric and the magnetic field both are, when it is in the y direction one thing and other one is in the x direction. The wave is in the z direction, okay. And in the tomorrow class we can see that it is oblique incidence for dielectric and oblique incidence for dielectric and the conductor. In this also we have to find out horizontal polarization and the vertical polarization.